Here we have a problem that the source of the problem says is a very advanced problem. I'm going to read the problem. Jihan and Kana are running a marathon. That doesn't tell me anything except that they're running. Due to the volume of people running, the starts occur in waves. Kana starts at 9:35 a.m. and runs at an average rate of 7 miles per hour. So we have a speed of 7 miles per hour. That's the wrong thing. We have a speed of 7 miles per hour. Kana is here. We break the problem down into manageable speed pieces. His speed equals 7 miles per hour. That's Kana. Jihan starts at 10 a.m. Problem is broken down into pieces. You have another person named Jihan. We're going to write J for that person and put his information on the right side. Jihan starts at 10 a.m. That's 25 minutes later than Kana and runs at an average rate of 8 miles per hour. So his speed, 8 miles per hour. Assuming constant paces, that means they're always running at 7 and or 8 miles per hour and no stops to the nearest tenth of a mile. In how many miles will Jihan catch up to Kana? Now, a marathon is 26.2 miles. So we expect Jihan, the one who is going faster, he's going at 8 miles per hour compared to Kana, who is going at 7 miles per hour. We expect the one that is going faster to eventually catch up to the one that is going slower. However, the one that is going slower got a 25-minute head start or jump on the one that is going faster, Jihan. So how are we going to approach a problem like this? We are going to have to find something that is the same with both of them, and we're going to have to use the formula that said speed equals distance over time in one of its 3 iterations to get the answer to this problem. There are 3 iterations for this formula. Speed equals distance over time. Student must know that. Or you could have distance equals speed times time. Student must also know that. Or you could have time equals distance over speed. Time t equals distance over speed. If you know these 3 formulas, which is actually one formula in 3 different ways, then you'll be able to decipher what is to be done. Now, we know that if they can model a race this way, as this has been the start, and this over here being the end of the race, and imagine that at some point in between the start and the end, the faster person catches up to the next person. Let's put this as a point right here. Put it in red. I love bright colors. Then it means that both of them would have traveled the same distance, but one would have traveled in a shorter amount of time. Keep that in mind. So let's start with the one on the left, Kana. Since he's traveling more slowly than Jihan, then let's assume that we're going to use the formula that says distance equals speed times time. Why? Because the distance is common to both of them. So, person on the left, which is Kana, his distance is equal to his speed, 7, times his time, t. However, this same distance that is covered by Kana is also covered by Jihan. But Jihan's speed is 8. However, Jihan's time is 25 minutes less than Kana's time. So we have to put t minus 25, okay? 25 minutes less than Kana's time. He started 25 minutes after Kana started, yet he covered the same distance. Therefore, he took less time to cover the same distance. So we have to write t minus 25. Now, since the 2 distances are the same, then it means that we can equate the right-hand side of each part of the formula. 7t equals 8 times t minus 25. We do some calculation, some math, and we end up with 8t minus 200. How did we get 200? We did 8 times 25, which gives 200. How did we get 8t? We did 8 times t. We used the distributive property. So we end up with 7t equals 8t minus 200. The next thing that we do is we isolate the variable on one side. You can do any side, but let's go ahead and do this. 8t minus 8t, we subtract the same thing from both sides. We end up with negative 1t equals negative 200, of which we divide by a negative 1, and we get time is 200 minutes. It took 200 minutes for the person going faster to catch up to the person going more slowly, even though the person going more slowly had gotten a 25-minute jump. Now, the question asked, assuming a constant pace and no stop to the nearest tenth of a mile, in how many miles will Jihan catch up to Kana? In how many miles? So we need that distance d. So since we calculated that distance d, we need to calculate that distance d. So since we calculated the time, then all we need to do is just substitute a time of 200 minutes into the equation. But there's a catch. The big catch is that we need to convert the minutes to hours. And if you have minutes to convert to hours, you simply divide by 60. Any number of minutes that you get, if you divide by 60, you get the number of hours. So if you have 120 minutes, right, you simply divide by 60 and you get 2 hours. And that works for anything, even fractions of a minute. If you have, of an hour, if you have 5 hours, sorry about that, if you have 5 minutes to convert to hours, you simply do 5 minutes divided by 60 and you get 1/12 of an hour. 5 12s make 65 into 5 goes one time. See? You get 1/12 of an hour. So 5 minutes is 1/12 of an hour. 30 minutes, just divide it by 60 and you get half an hour, which everyone knows is the case. 15 minutes, divided by 60, you get a quarter of an hour. So anytime you want to change minutes to hours, you simply divide the number of minutes, whatever the given minutes is, by 60. So we have t equals 200. We decided that we are going to make a substitution in one of the equations. Anyone will do, but I chose this equation since it's simpler than this one. So we're going to do 200 distance equals 7 times or 7 miles per 1 hour times the 200, which we have to convert the 200 to hours. So we have 200 minutes divided by 60, which gives the number of hours. The units cancel. I'm a big fan of cancelling units and keeping units intact. And we end up getting distance d equals, and we do the calculation. 7, we cancel these. We end up with 7 2s, 140 divided by 6, right? Which works out to be miles, in miles, which is 70 divided by 3, which works out to be equal to 23.3333 miles. So after 23 miles, the person going faster will have caught up to the person who was going more slowly. This is how you do these kinds of problems.